The year is 40,000 BC. A small tribe of early humans settles near a river in what will one day be called Europe. There are 23 of them. They hunt together, sleep close to the fire, share food from the same hands. They have survived droughts, predators, brutal winters. They are not fragile. But tonight, one of the hunters comes back from the forest slower than usual. His eyes are heavy. His skin burns. By morning, 2 more wake up the same way. By the 3rd day, the children start coughing. The tribe has no word for virus. They have no concept of an invisible enemy. But they know something is moving through them. This is not a story about weakness. This is a story about how early humans, with no medicine, no science, and no understanding of microbiology, developed survival systems so effective that without them, none of us would be here today. The first thing that happens inside any tribe when sickness spreads is a shift in behavior, and it happens fast. Researchers studying isolated hunter-gatherer communities that still exist today have found something remarkable. The moment one member shows signs of illness, the group instinctively reorganizes. Not because someone gives an order, because the body reads the social environment and responds. The sick person moves to the edge, not always by force, often by instinct. The ill hunter doesn't sleep in the center of the group anymore. He drifts. The others leave space. Children are pulled closer to healthy adults. This is not cruelty. This is biology operating at the group level. Every social mammal on Earth does some version of this: chimpanzees, wolves, elephants. The human version is just more deliberate. But early humans didn't only separate. They also cared, and this is what makes them distinct from almost every other species on the planet. Anthropological records and fossil evidence show something that scientists didn't expect when they first started studying Neanderthals and early Homo sapiens. Old injuries that healed, broken bones that were reset and recovered, degenerative diseases in individuals who clearly survived for years after the onset. These were people who couldn't hunt, couldn't gather, couldn't contribute, and they were kept alive anyway. Somebody fed them. Somebody stayed. That combination, separation, and care, is the oldest infection control system in human history. And it worked not because anyone understood germ theory, but because natural selection had already been running that experiment for hundreds of thousands of years. Tribes that abandoned their sick died out faster. Tribes that found the balance between distance and care had better long-term survival rates. Now, what did they actually do with the sick? What did the tribe's healer, the oldest woman, the most experienced hunter turned elder, reach for when the fever came? Plants, specific ones, and not randomly. Ethnobotanists, scientists who study the relationship between human cultures and plants, have found that across every continent, isolated from each other by thousands of miles and thousands of years, early human groups independently discovered the same categories of plants for treating the same categories of symptoms: fever, infection, inflammation, respiratory distress. Willow bark, which contains the compound salicin, the natural predecessor to aspirin, was used in cultures across Europe, North Africa, and the Americas with no contact between them. Certain molds and fungi were applied to wounds because they visibly stopped infection, long before Alexander Fleming identified penicillin in 1928. Garlic was found in ancient Egyptian medical papyri as a treatment for infections. Modern research has confirmed it carries real antimicrobial properties. Early humans weren't guessing. They were running the longest clinical trial in history, generation after generation observing, eliminating what failed, keeping what worked. The knowledge didn't live in books. It lived in memory, passed from elder to child around the same fire where the sick person coughed. But the virus doesn't care about plants or fire or memory, and sometimes it wins. When death starts moving through a tribe, something else happens. Something that scientists now believe was one of the most critical evolutionary developments in human social behavior: ritual. The body of the dead is handled with urgency. In most early cultures across the archaeological record, the dead are buried quickly, often with specific materials. Red ochre, which carries antimicrobial properties, was placed with bodies across Neanderthal and early Homo sapiens burial sites in patterns too consistent to be coincidence. Whether they understood why or not, they were doing something that reduced the spread of whatever had killed the person. The ritual and the survival strategy had merged into one action. Grief was processed collectively. The tribe gathered. Songs or sounds were made. This is not a small detail. Collective emotional processing after loss has been shown in modern psychology to reduce the cortisol crash that follows bereavement. High cortisol crashes suppress immune function. Early humans, by grieving together, were physiologically protecting the survivors. And then the tribe made a decision that would define human survival for the next 40,000 years. They moved, not always, not immediately, but when the sickness didn't stop, when the river smelled wrong, when too many people were sleeping against the rocks, they left. Hunter-gatherer groups are nomadic not only because of food. The rotation of campsites is one of the most effective parasite and pathogen control systems ever developed. A group that stays in one place long enough gives parasites, bacteria, and viruses time to build population density in that environment. A group that moves disrupts that cycle completely. The campsite they leave behind becomes clean ground. The one they move to hasn't seen their biology yet. They carry their immune memories with them. The virus has to start over. Here is what 40,000 years of viral outbreaks in small tribes actually produced: a species with one of the most complex and aggressive immune systems ever evolved. The human immune response is not subtle. It is catastrophic by design. Fever, inflammation, full systemic mobilization, because the tribes that had the most violent immune responses survived the most outbreaks. The ones with mild responses died quietly and left no descendants. Every fever a person runs today is the result of ancestors who ran that same fever and lived. Every inflammatory response is inherited from a long line of bodies that fought this exact kind of war and won enough times to pass the code forward. The tribe in 40,000 BC near the river in Europe, some of them die. The ones who were already weakened, the very young, the very old. 3 of the 23 don't wake up. The others grieve, bury them quickly, apply what the elder knows, keep the fire between the sick and the well, wait, and eventually, the fire inside the sick ones begins to cool. 14 days after the first hunter came back slow from the forest, the tribe moves camp. They leave the river. They go north, toward higher ground where they've camped before. The air is colder. The water is cleaner. The sick ones walk slower, but they walk. 3 months later, a child is born to one of the women who survived the fever. That child carries, in every cell, the memory of what just happened. Not a thought, not a word, a molecular record, an immune system slightly more calibrated than the generation before. This is how the species learned to survive what it could not see, could not name, and could not stop. Not through intelligence alone, through behavior, instinct, accumulated knowledge, and the oldest survival technology on Earth, each other.